In this next video, we're going to explore the relationship between fractional exponents and radicals. So in this first question, or this first expression that we have 27 to the exponent of 2/3. So we want to know how we can rewrite this expression as a radical. So there are two different ways that we can do this. The first way is like this. So we write our radical, and the value that is in the bottom of the fraction that's in our exponent goes in the index in the radical, right? That's always going to be the case. And then the numerator of our exponent just stays as the exponent with the base in the radicand. So this is one way that we can do this, and you may have heard there's like root and flour. You can kind of think of it that way, so 2 being the flour and 3 being the root. In this way, it makes it a little bit more difficult to evaluate the expression because, we're probably, if the numbers are large, 27 squared is quite a large number for us to do without a calculator. So this next method is going to make it a little bit easier for us to actually calculate this expression without the use of technology. So we can also write it like this, and that is equivalent, right? 1, 2, and our initial expression with a fractional exponent, these three are all the same. So with this next one, we can see that we can actually evaluate this. So the cube root of 27 we know is just 3. And then we can just square that answer to get 9. So let's look at another example. In this example, we have 16 over 81 raised to the exponent of 1/4. So we can rewrite this and use one of the laws that one of our exponent laws that we know. And if we have, basically what we're saying is if we have a quotient, we can raise both the numerator and the denominator to the exponent that's on the outside. And now we can evaluate each part. So 16 to the exponent of 1/4 is the same thing as the 4th root of 16. And similarly, 81 to the exponent of 1/4 is equivalent to the 4th root of 81. And we know that the 4th root of 16 is just equal to 2, and the 4th root of 81 is equal to 3. And we're done. Let's just do a couple more examples. So in this one we have negative 27 raised to the exponent of 4/3. We can rewrite this knowing our knowledge that we just learned about how to convert it into a radical expression. So we write our root, and then the denominator of the exponent goes in the index. and then we can raise the whole thing to the exponent of 4. So then we can evaluate the cube root of negative 27 is going to be equal to negative 3, which we can raise to the exponent of 4, which is going to give us an answer of 81. And finally, let's look at 81 raised to the exponent of 3 over 4. We can follow the exact same procedure. We write our root. The denominator of 4 goes in the index, and then our base goes in the radicand, and then we can raise the whole thing to the exponent of 3. We know that the fourth root of 81 is equal to 3. So we replace what's inside our brackets with 3, and then we raise that to the exponent of 3. So 3 cubed is equal to 27. And again, if it makes it easier to do these questions at the beginning, you should have a chart with you that lists all the perfect squares, all the perfect cubes, and so forth.